students. Today we discuss in chemistry 11th standard the name of topic element of group 13, 14 and 15. Today we discuss the reactivity towards air, oxygen, reaction with water, reaction with halogen, catenation property and the allotrope of carbon. When you study this property, firstly we understand the bonding in compounds of group 13, 14 and 15 element. First one, the lighter element in group 13, 14 and 15 have small atomic radii and high ionization enthalpy. They form covalent bond with other atom by overlap of valence shell orbital. When we move down the group, ionization enthalpies are lower in group 13, 14 and 15. Heavier element in this group form ionic bond. Boron, carbon and nitrogen can't expand their octet. The subsequent element in group have vacant d orbital in their valence shell which can expand octet, form variety of compounds. Next, we study the reactivity towards air or the oxygen, non-reactive mixture of a gas, that is the air, which contain oxygen and the number of gases in group 13. When group 13 element heated with air or O2, oxygen produce oxide. Here in this reaction representation, E become equal to the element of group 13. These are boron, aluminium, gallium, indium and thallium. When for E plus thrice O2 which gives twice EtO3, twice E plus N2 which gives rise to twice En. In group 14, when group 14 element carbon, silicon, germanium, tin and lead which is heated with air or oxygen, it produces the monoxide and dioxide. There is a formation of monoxide, there is a formation of dioxide. While in group 15, when element of group 15, the group 15 element which are nitrogen, phosphorus, arsenic, antimony and bismuth, when heated with air or oxygen which produce oxide, and this oxide become E2O3 or E2O5, trioxide or pentoxide. When P4 plus thrice O2, it gives P4O6. P4 plus 5O2, it gives P4O10. AS4 plus thrice O2, it gives AS4O6. Then here there are some stable oxide of group 13, 14 and 15. When we move down, the metallic character increases down the group. Here the metallic character increases down the group. Boron to thallium, carbon to lead, nitrogen to bismuth. Then it reflects their oxide which vary from acidic to amphoteric to basic. In group 13, acidic, amphoteric to basic. In same thing, 14, acidic, amphoteric. While in group 15, these are acidic, these two amphoteric, while Bi2O3, it become basic. We represent here, it reflects their oxide which vary from acidic, amphoteric and basic. Next property, the reaction with water. Most of element of group 13, 14 and 15 are unaffected by water. The aluminum react with water with heat form hydroxide. When aluminum react with water, it form the aluminum hydroxide, while the tin reacts with steam to form oxide. Tin, it will be treated with water which is found in environment in a three state: solid, liquid and gas. Gas, it becomes a steam. When SN treated with twice H2O, it formed SNO2 oxide formation and the evolution of hydrogen gas, while the lead unaffected by water because the formation of protective film of oxide. Next, the reaction with halogen. All elements of group 13 it react with halogen form trihalide EX3 except thallium. Thallium doesn't form trihalide. The representation of an reaction twice E plus thrice X2 gives rise to twice EX3. All elements of group 14 except carbon react directly with halogen form EX4. Germanium and lead form dihalide. Elements of group 15 react with halogen form trihalide and pentahalide. The ionic character of halides increases down the group, while the nitrogen do not form pentahalides. That is the EX5. Next property, the catenation. In this catenation, firstly we study the definition. The definition of catenation. The property of linking of atoms of an element by covalent bond to form chain and ring called catenation. Catenation tendency depend on strength of bond form. In group 14, carbon show maximum tendency. Because why the carbon show maximum tendency to form a catenation? Because the stronger carbon-carbon bond, it becomes 348 kilojoule mole inverse. The bond strength order, carbon is much more greater than silicon, while the silicon is greater than germanium, and germanium and tin having the same tendency to formation of a catenation, while the lead it doesn't show the catenation property. Next, allotropy. Then what is the allotropy? When a solid element exists in different crystalline form with different physical property like color, density, melting point, called as allotropy. While the individual crystalline forms are called allotropes. There are some allotropes of an carbon, diamond, graphite, fullerene, graphene, and carbon nanotube. One by one we discuss the allotrope of carbon. Here the structure and hybridization and the uses. The firstly we study the first allotrope of carbon, diamond. In this diamond, here it is the structure of diamond. In this structure, each carbon atom linked to 4 carbon atoms into tetrahedral manner. Carbon-carbon bond distance is 154 picometer. The tetrahedral linked together form three-dimensional network structure. Thus, the diamond is the hardest natural substance. Diamond is the very hardest natural substance. It have the high melting point. It become 3930 degree. It is a bad conductor of electricity. Then this diamond, which is used in cutting glass in drilling tools, making dies for drawing thin wire from metal. It is also used in making jewelry. Next, allotrope of carbon. It is a graphite. In this graphite, it composed of layer of two-dimensional sheets of carbon atom is being made up of hexagonal net of sp2 carbon bonded to three neighbors, forming three bonds. That is very simple. One carbon bonded to another three carbon. One carbon is bonded to another three carbon. It undergoes sp2 hybridization. It forms 3 sigma and 4 electron form pi bond. The bond length in carbon-carbon is 141.5 picometer. Here it is the bond length which is represented by, and the bond length it become 141.5 picometer. Individual layer held by weak van der Waals forces separated by 335 picometer. Here the one with the first layer, second layer, third layer. This first layer and second layer which is separated by 335 picometer. Graphite is very soft. It become slippery, and graphite is the most stable form of carbon. Next, allotrope. It will become fullerene. The allotrope of carbon in which carbon molecule linked by definite number of carbon atom. For example, C60. It is the example of fullerene. Graphite electrode heated with an electric arc in presence of inert atmosphere, helium or argon, to form fullerene. There are some examples: C32, C50, C70 and C84. We study C60, the shape of fullerene, soccer ball called Buckminster fullerene. Here the structure of Buckminster fullerene or buckyball. This structure which contain 20 hexagon. Here it contains the 20 hexagon. Here 1, 2, 3, 4, 5, 6. There are the 20 hexagon. Here the first, here the second, here the third. There are 20 and 12 pentagonal. Here the 12. 1, 2, 3, 4, 5. 12 pentagonal fused ring of carbon are sp2 hybridized. It becomes covalent. It is soluble in organic solvent. Then what are the organic solvent? Benzene, CdCl3, isopropyl alcohol, ether. Fullerene C60 react with group first metal from K3C60, while the K3C60 behave as superconductor below 18 Kelvin. That is, it carries electric current with zero resistance. Next, allotrope of carbon, it becomes the carbon nanotube, which is cylindrical in shape. It consists rolled up graphite sheet. It can be single walled with diameter less than 1 nanometer or multi-walled with diameter more than 100 nanometer. Single walled would become 1 nanometer, multi-walled with diameter more than 100 nanometer. Carbon nanotube are robust. They can be bent, but when they released, they will spring back original shape. It have high conductivity, high strain, but the important thing we must notice the researchers are combine carbon nanotube with other material into composite. They can be used to build lightweight spacecraft. And the last allotrope of carbon is a graphene. The graphene is discovered by Jim and Novoselov. He awarded by Nobel Prize in 2010. Isolated layer of graphite is called graphene. Graphene sheet is two-dimensional solid, and the graphene, it has unique electronic property. Thank you. That's the day.